I'm David Black, and welcome to this software training video. Today, I will walk you through examples of how to incorporate 3D modeling and animation workflows into your science media creation projects. I've already created some videos to teach you how to use SculptGL and Tinkercad, including how to create textures in SculptGL and then move them through Photoshop and through Clara.io, and from there into Mixamo to rig and animate the characters. Now that is one workflow, but there are quite a few others that you still need to learn.
The following diagram shows how various 3D software applications can be used interchangeably depending on what you want to achieve. Now it looks incredibly complex, but it doesn't need to be if you know what your final goal is. The yellow circles are free online software tools that can be used on most computers, including Chromebooks and iPads. The aqua circles indicate free software, but it must be downloaded and installed on your local computer, and will therefore not work with a Chromebook. As much as possible, I'm focusing on browser-based software in these videos. Now the pink color is for Photoshop. It's the only commercial software shown here that I think is pretty much indispensable because it can be used to convert grayscale terrain data into 3D models, it can convert textures into UV maps, and it can pose 3D models in front of background images. Otherwise, Photopea can be used to stack, fix, and edit 3D rendered still images or screen captures.
So today I'm going to walk you through 5 different 3D modeling workflows that you can use in your science media creations. I'll be going through these workflows fairly quickly because they're meant to be examples and just an overview. We'll go into more detail in later videos. Ultimately, I want to teach you how to use 3D images, animations, and interactivity for your science media creation projects and to demonstrate mastery of science concepts. If all you need is just a still image of a 3D scene or a 3D model to use in a presentation or a graphic, then this is one workflow that's fairly straightforward. Instead of having to create a model from scratch inside SculptGL or Tinkercad, you can often find them for free online and then load them into the software and make whatever modifications you want. Ultimately then, taking images of them or even importing the model itself into Photoshop and incorporating that with a background. I've taught you how to use various 3D objects inside SculptGL and Tinkercad, but not where to find free models online.
There are many free 3D models available, such as these models we printed for our Museum of Extinct Life. Do a search for free 3D models, then visit different websites to find what you need, such as Thingiverse or free3d.com. Just be careful how you search, as you may run into some models that are not appropriate for high school students. As a teacher, you may want to download the models yourself. If you can't find a free model for what you want, you can always create a new one in SculptGL, SketchUp Free, Clara.io, or Tinkercad, and then work the model between those programs. SketchUp is for designing architecture and furniture. Clara.io is a full-featured browser-based modeling and animation program. SculptGL, as you've already learned, can create organic free-form models and paint on textures, and Tinkercad allows for Boolean commands and precise alignment and rotation. Once the model is made, import it into SculptGL and use the painting tools to create a texture. In the second SculptGL video, I've already shown you how to convert the OBJ texture into a UV map in Photoshop and then use Clara.io to create an FBX file that can be imported into Mixamo for rigging and animation. But if all you need is a posed and textured model in a still scene, then you can apply a background image in Photoshop and save it as a PSD or JPEG, or use some careful layer masking in Photopea. Or you can choose and rotate individual bones from the Mixamo file in Clara.io, and then add a background image to a two-dimensional plane with lights. There are many possibilities.
If your goal is to create a humanoid figure and then animate it, A good place to start is Adobe Mixamo itself. There are a lot of characters already in there that have already been rigged. All you have to do is choose animations. But if you want to create something yourself, rather than building an entire humanoid figure from scratch, there is a program called Make Human.
Make Human is a desktop program and needs to be installed, but allows you to modify a basic human figure with a series of morph targets. Choose clothing and hair, and then export it as an OBJ to SculptGL, where other details can be added, such as better hair, wrinkles, beards, and other textures. From SculptGL, the model can be exported as a new OBJ and the material as an MTL. The material and the model will need to be in the same folder, which must be converted into a zipped file. You can then import it into Mixamo and add rigging and animation. If your model comes from Make Human or elsewhere, load the model into Mixamo and go through the auto-rigging process. Then choose a sequence of animations. If you don't need to add a complete scene, you can pick the view and play the animation while doing a video screen capture and save it as a QuickTime movie. The animated file can also be loaded into Clara.io and the whole thing rendered out as a screen capture to a QuickTime animation.
Yet another pathway for your 3D models and animations is to start at Mixamo with a character and then export it directly into Adobe Aero. Now, this is a program that Adobe is developing. It's still in beta as of this recording, and so it's free. Now, Aero is an augmented reality program, so it allows you to load it up into the Aero app on your phone and then paste it into a scene and anchor it to a plane, and then you can also program it to do various things. We've hinted about this program before, but we also need to show you how it works.
In addition to the 3D animated FBX or GLTB files that you bring in to Adobe Aero, you can also bring in layered images from Adobe Photoshop or Illustrator. All you have to do is stack the layers on top of each other, make sure that any groups are compressed into their own layer, and then the entire image can be brought into Adobe Aero, and then you can use the Z-axis to separate the different layers to provide the illusion of depth. Such a file is essentially a series of stacked billboards, or what we would call 2.5D instead of true 3D. But by moving around in the scene, the billboards move compared to each other, and they preserve the illusion of parallax. Now, once inside Aero, triggers and actions can be applied, such as choosing and playing animations from your FBX characters, or spinning or bouncing or whatever. These are actions that are already available inside of Aero. You can do the same with different layers inside your 2.5D objects. When the scene is previewed, it will play the model onto a scanned surface. The animated files can be moved along a path, and the animation clips sequenced. Since end-user actions trigger the animations, the experience is interactive. Now imagine all the things that you could do with augmented reality. If you were inside of a museum, the different signs could have QR codes on them, so as you scan them with the QR scanner app on your cell phone, an Adobe Aero scene would pop up and you'd have a 3D modeled and animated dinosaur roaring and chomping around inside, say, a paleontology museum with dinosaur bones.
One area where you can really stand out as a science student is to actually visualize scientific data in 3D. This might sound like a very difficult thing, but it's actually not that bad. You see, a lot of scientific data is posted online and it's available for free, as long as you know where to find it and how to use it. For example, 3D terrain models of Mars and the Moon and Earth are all available online. You just have to download them and then use them to create a 3D model and put a texture on it. The reason this is available for free is it is actually supported by your tax dollars. You see, all of these different scientific studies that got the data in the first place were supported from the National Science Foundation, from NASA, or from some other government agency, which is supported by your tax dollars. And so you've already paid for it. Once the principal investigators on these projects have had a crack at using the data, usually a year or so, the data must be posted online. It's required by the government, and then anyone can access it and use it. So you can do all kinds of science projects by using this big data that's already posted online. My students have successfully used this data to create quite a few different projects, including doing 3D models of the moon, the Earth, Mars, Mercury, and a lot of other astrophysics data that they've used. They've created posters and then presented these posters at professional science conferences. It's amazing what you can do. Others have gone on to create their own science fair projects and have taken them all the way to the International Science and Engineering Fair.
Free 3D terrain data is available for Mars and the Moon at the NASA website. It's called the PDS Geosciences node at the Washington University in St. Louis. And data for Earth is available at the USGS Earth Explorer website. This is all in the form of grayscale height maps. All you have to do is select your desired area, and in the case of the USGS Earth data, the best data is the Shuttle Radar Topography Mission data, or SRTM. Then you download the height map, and then what you need to do is take it into Adobe Photoshop. Now, it might need to be a slightly older version of Photoshop because the most recent versions, they are beginning to take out the 3D features. But if you can find an older version of Photoshop from a couple of years ago, load the height map into Photoshop, and then if you go under the 3D menu, you choose Create Mesh from Layer, and then you can export it as an OBJ. Now, the vertical axis will probably be very exaggerated, and so you'll need to import it into SculptGL and use the Transform tool to turn down the vertical axis, and then add a base so that it will 3D print correctly. It can also be exported as an OBJ to Clara.io or Blender or other programs and then used for background mountains or for other uses. Alternatively, the original terrain height map, the grayscale image, can be read directly by Blender or by Terragen, which is a program that has a complete ability to create a scene out of your terrain models. It can build clouds and atmospherics and lighting effects, and it's quite realistic.
A fifth and final workflow that I will show you today is how to use still images that have been captured from 3D animations and then brought into programs such as WikEditor and Scratch to create interactive programs.
Now, inside SculptGL or Tinkercad or Mixamo, one can render out and save the textured model as a series of still screen captures. You could, for example, use QuickTime to do a screen capture of the plane animation inside Mixamo, and then go into that QuickTime file and save out still images from each one of the frames. It is a tedious process, but it gives you complete control on how those frames are going to be shown. For example, inside Tinkercad, our gray alien can be rotated 10 or 15 degrees at a time, and then a series of 24 images can be captured out. Once you have all of the separate images imported and perfectly aligned in Photopea or Photoshop, you'll need to crop the images so that each layer has an identical size, and then each layer will need to be re-exported as newly named files. Yes, it is quite a process. Then these sequential files can be imported into WikEditor and placed in separate frames on the timeline and turned into a film loop for a continuous animation. In MIT Scratch, the separate images can be imported as different sequential costumes for a sprite, which can be changed and controlled through costume control bricks. It can switch costumes automatically as soon as the green flag is clicked and appear to rotate in the background, or it can be controlled by buttons interactively, as you see here with our dancing gray alien.
You've already learned the basics of using SculptGL and Tinkercad from my previous videos. Hopefully you've had a chance to practice that, but you still need to have some videos on how to use Clara.io and SketchUp. Those will be coming shortly.
As we've been going along, I've showed you some examples of how you can incorporate 3D modeling into your science media projects, but we've only just barely scratched the surface. Now, this is useful even if you only want to show a 3D still image in a presentation. But as I've shown you here, you are limited only by your imagination.
The skills you learn here will go far beyond your science education. These skills will actually translate into career pathways for you to go and do many different things. For example, there's a huge need for being able to visualize scientific data. All you need to do is practice and take the time to master these skills. It's going to be fun. Thank you for watching, and as always, keep on learning.